Welcome back to the stream. Had to reset chat there just to see if it was working, but there we are. Nice stream. I'm glad you're liking it so far. We're only a couple seconds in. Anyway, welcome back. If you're here for the first time, welcome. For a little bit of context, this is a... excuse me. Really should have taken a swig of tea before starting the stream rather than right after. So this is sort of a, virtual making stuff kind of hangout where I'm working on projects that eventually turn into edited together video blogs. But if you want to watch stuff happen in real time and hang out in the process, that's what this is for. And I'm Micah, aka Scanlime. My cat Tuco is meowing in the background. This project we're working on right now is an aerial camera that can hang out with Tuco. And right now I've actually got 3 of the 4 winches in operation. Oh, why is this camera not live? I thought I just went through and fixed all the cameras. There we go. Alright, this one's a little laggy, but it's the overhead camera. Right now I've got 3 of the 4 winches up, and you can actually see a hovering spool of wire. It's kind of hard to tell which spool of wire is hovering because there's so much junk around here. In this view, it's actually directly above the cat litter box, which is sort of down and to the right or to the left from the date stamp on the photo. But I'm going to try to actually move this around. So we were starting to, in the last stream, code up an automatic, or like a semi-automated navigation mode, so we can move around multiple winches at once, adjust the tension when the winches start getting slack. But while we were working on that, I managed to totally jam up one of the winches by letting it run with too little tension. And in hindsight, I think actually the most likely root cause of this was a combination of both working on code that was exploring this low tension region of operation, and I think also maybe the tension sensor, so the force sensor, might have actually already been out of calibration, so we might have actually been operating with even lower tension than we thought. So they're probably a combination of factors, but some of those factors causing us to run with low tension ended up causing that winch to jam, such that the cord kind of wound itself around the gears. And that's not the end of the world. We actually had that happen to one of the other winches and just successfully unjammed it. But I think it happened particularly badly on this winch, and I didn't really know what had happened until it was too late. And that combined with some factors that weakened the gear in the gearbox led to a broken gear. And so I think the gear, I think it was a combination of factors there too. I think it was a bad design to begin with. It was this pin that was hammered into a plastic gear, and then, oh, hey picture, why did we just lose you? There's a pin that got hammered in through this hole in a plastic gear and then kind of melted into place kind of badly. Yeah, so just a whole bunch of factors combining to make this bad. And then I think I made the situation a lot worse by opening this motor and then adding some different lubricant that might have been bad for this plastic. And the only reason I did that in the first place is I was trying to diagnose some different problems I was having where the motor worked, but it was a little bit wobbly. Because this was the motor I was using for some earlier tests on the very first spool design, where I was mounting the spool directly to the motor. It didn't work very well, and it also exacerbated the problem with this motor not being especially straight. Yeah, it turns out that after taking these motors apart, this does not nearly have enough, the bearings on this motor just would not be able to support the spool on its own. It has a bushing on one side and a tiny bearing on the other side. So this motor, I'm not gonna trust the gearbox to support much more than just the output gear. So speaking of the output gear, we had to destructively disassemble it to take this whole thing apart, which was the plan. This is not the first or the second, or maybe even the third time I've had to take this one of these gears off because of all the earlier development and testing. But this is just how this is designed to work. I had tried other strategies. Some of the other wheels that I use in this design have set screws, but the problem is I didn't have, in my experience, I couldn't get like a set screw based design to be very strong and very concentric. I also didn't really have room to, to leave any kind of hole in the gear surface, and I didn't have room to like leave a shoulder up here that would support the set screw really. So a lot of factors coming together meant that the best design I could come up with for this gear was something that you hammer on and then cut to take off. So printed a replacement hub for that, and the flexible part is printing here, and oh man, yeah, these cameras apparently are not very reliable right now. I'll have to restart this one. There we go. So yeah, there's the NinjaFlex exterior printing. So that's happening. On the last stream, the plan was to 3D print a replacement for the broken gear. So I'll show you how that goes on in a sec. I think I actually need to put some gloves on, because it is, you know what time it is? I think it is Shmoo 30. Here's a glove. Oh, there's the others. I didn't even have to get up for that. I'm already getting some of that silicone lube on my fingers just from handling that broken gear. Oh, interesting. Station 240 is wondering if anybody else is getting a bunch of 500 internal server errors from YouTube. Yeah, I don't know. A lot of the YouTube errors that people seem to periodically have are probably geographical. So like maybe people on certain edge servers are having problems and others they're not. I'm actually going to chuck out this broken gear. I don't think we need this anymore, and it's just a lubey, melty mess right now. Just wanted to get maybe another photo of it before I throw it away. So yeah, that's a perfectly good gear that I had to cut to open the broken gearbox. Not a big loss, since it's basically just like an hour or two of 3D printing. Oh, nice. Ben got here out of a work meeting just in time for the Shmoo. Awesome. We also got some random sunlight coming in here. There's not a lot I can do about this particular sunbeam right now, but it'll be gone in probably 10 minutes, so let's just deal with that. Let's actually get a closer view of the original gear. So, and so this is actually new Shmoo. One of the tedious things that we did on the last stream was to like fully clean and degrease the old parts, and then reapply grease that is definitely safe for plastics. So I had a mixture of probably like lithium grease and like some kind of thick oil that it came with. Let's go to manual focus. And so I cleaned all that out and replaced it with silicone Teflon lubricant, which should be fine for the metal pieces and should be great for the plastic. So yeah, the way this goes together, this piece is, this is a shaft that was turned on a lathe to get these different indentations and features. There is a hole drilled here and a pin hammered in. The pin looks like it was hammered in with the gear in place. There's a pocket milled where a key fits in there, which is this thing. And that's about it for the axle. The side with the key holds this other gear, which just holds that nicely against that shoulder. Already some nice Shmoo coming out. And then the original plastic gear fit either like that or like this. Like that. Fits right up against that shoulder. So there's a small gap of like maybe 1 millimeter between the two gears, and then a nice surface to fit in. I think both of these sides fit in bushings. So yeah, at first I was assuming actually that this thing was actually molded over the shaft, which seems like it would have been the strong way to do it, but no, I think it was actually just like hammered in. So we looked at it under the microscope, and it looked like there was pretty clear evidence that there was a hole in the gear already, that they hammered the pin in from one side, and then just like melted over the entry point over here to keep the pin from backing out. And it's not good at all. And then there's another kind of chowdering, I guess, as you would say over here, where there's some like circular divots cut out of the gear, and that seems to be there only on one of the halves. So that could have happened just by the worm gear grinding at this after the two halves were separate, or maybe it could be that it started kind of levering one side away while simultaneously grinding the other side, maybe. But this gear split pretty well. Doesn't seem like it was a very good design, and then on top of that it was subject to a little bit of abuse by me. So yeah, this on the downside, this design seems pretty terrible. On the upside, it might be easy to fix. So my plan for this, we ditch this gear, keep the whole shaft assembly, and then we designed and 3D printed a thing on the last stream that should just slip back over this, and then assuming that all fits together, I can use epoxy to form a strong sort of keyway between the pins and the channels that I left in the plastic. And I actually have one that we printed on the last stream actually was totally wrong, because I had just gotten confused about how this mounted at the time, and I assumed this would fit kind of this way, but of course it doesn't. It fits like that way, and so the pockets have to be oriented the other direction. And also the inner diameter was just too narrow here. So we already knew on the last stream that this one was no good, so this one's trash also. Oh well. Oh, and as far as material, this is all printed out of... Most of my printing is PLA, but I wanted to try something high strength for these, so it's printed fairly solid out of PETG. Or no, it's not PETG, it's PET Plus, the made solid stuff. Not quite sure what chemically the plus stands for. So, if we did this right, I have not tried this yet. If we did this right, this should fit together kind of like this. And it's a tight fit, which is better than a loose fit. Hopefully it fits at all. I think my printer might have just been over extruding a bit for this whole print, which might be bad. Oh, I think it's fitting. It might be time to take this to the vise. It's going to be that hard to get on. It's, I hope it doesn't get stuck on here, because I do need to put epoxy on there. Oh gosh. Are these pins not lining up? You know, I just noticed this. The hole the pin is put through is not centered. What? That's off center. I didn't notice that at all. I just assumed it was straight through the center. Well, we might be able to force this together in some capacity. I mean, I left a little bit of clearance, but probably not that much. I'm just gonna see how far I get with the pan of ice. I don't know why that would be off center. That's really strange. Extrusion multiplier. I don't know. Does Kira even use that terminology? All the slicers have different terminology. I was going to touch the gear. I didn't get that much lube on the gear. I think we're mushing that together. Yeah. I need a block with a hole in it on the other side. What do I have that would work? Maybe a large nut. This is too large a nut. This one's just right. Flow percentage. I mean, I thought the whole point of flow percentage was like, okay, something is already wrong elsewhere in your calculations. You're just going to bodge it at the very last moment. So like we could do it that way, but there's probably another way to do it also. This is turning out to be a tight fit. We might be able to test this without even putting epoxy in. Ooh, I think I'm getting the nut stuck on there now. Uh-oh. I might need a larger nut. Yeah, I need something larger. Let me look for a different bit of hardware for that. That was an M8 nut. It's a little small for this. I don't have a lot of really large hardware here. Any big washers? Maybe these? Oh, I think this will work. Yeah. Just keep all them things stacked. Yeah, well, maybe, oh, here we go. Is that better? Yeah. I think we just kind of brute forced our way through the pin misalignment there, but the gear is probably a little bit crooked as a result. Let me see if I can fix the crookedness with the vise. That's not bad. Let's just try that in the gearbox and see if this is even remotely the right size. Because this is all based on some guesses and some bad trigonometry. Yeah, so actually the problem that was taking so much time last time, I just couldn't find a definitive way to just measure a gear. And so I guess maybe this is just a harder problem than I gave it credit for. There were strategies where if you were designing a gear, you could calculate some measurements, which you could then perform on the gear by putting pins in between the teeth. But I couldn't find a straightforward way of going backwards from those measurements to possible geometries that the gear might have started out with. And it seemed like that might have actually been a harder problem than I was anticipating too. So we just kind of eyeballed it. Well, so then I came across the hint that gears a lot of the time use like very standard numbers for the module, which is one of the design parameters. And so I looked at some candidates, and this one seemed really close to 1 millimeter, so I just tried using 1 millimeter, and that's what we're doing. There's a little bit of PLA scrap on the edge here. That very first layer did not adhere very well on this print. Okay. So, let's just see if this works with the worm gear at all. Ooh. That looks really nice, actually. Oh, yeah. Yeah. I say we assemble the gearbox with just kind of minimal extra lubrication and without epoxying the gear in, and then just see how well it runs. And if it runs at all well, then I think we just put some epoxy in and then do some more tests after that cures. So now I just have to remember how to assemble the gearbox. There's a bearing for the output shaft. There's the output shaft itself, which is a little bit weird. There's a spacer that goes on this side. I'll need to properly lubricate this all when I put it back together again, but yeah, I didn't need to take this clip off at all, really, except to get the old lube off. So that clip can just stay there. It's keeping the gear on, but the gear is also just pressed very tightly, so it's not really going anywhere. And then there's an O-ring, which kind of cushions between the clip and the sleeve that goes over it. And the sleeve, this is like a spacer. At least I think that's how this whole thing goes. So then that mates with that gear and presses somewhere into the bushing. Yeah, those are mated. Look at all that shmoo. Oh yeah. That is definitely a shmoo o'clock. Okay, so I'm going to take these gloves off and power up the motor a little. I guess I should put at least a couple of screws in the bearing case, or the gearbox rather. Yeah, let's just put a couple of screws in there, just because I don't want that wandering off and misaligning all the shafts. I know I'm using the wrong kind of screwdriver. Okay. There's shmoo everywhere. Alright. That feels like a worm gear should feel. That's nice. Let's get the power supply warmed up. Let's just give it a couple of volts first. That gear was very easy to install, and it might be that the off-centeredness of the shaft is not a big deal, and I can just chalk it up to their sloppy tolerances. I can play that sloppy tolerances game too. Okay, I've just got like 2 volts. I don't even know if the motor will start, but let's try this. Ooh. It was turning. Oh, I hit current limit. I only had the current limit set to 0.5 amp. Let's bump that up to like an amp or so, 1.5 amps. Okay, it needs a little more voltage. I think it's actually stalled. I'm gonna give it a little more current, but I think it's stalled. Yeah, that... Oh, no, there it goes. Okay. Hear that? Let's run it at higher speed for a little while and then open it up and see how it looks inside. It also does not have very much lube, so I'm not going to run it much. And it's only got 4 volts, and this is a 24 volt motor. Oh, it is knocking. Yeah. Let's see how it looks inside. That would be usable, maybe. We got up to like 20 volts there. Sorry, I'm a little behind on the chat, everybody. Use the other 3D printed gear. Which one was that? Oh, you mean of the 2 I printed? Yeah, I was making sure I had the 2 straight. Releasing the shmoo again. Is this a re-release of the shmoo rerun? Whoa. What is going on in there? I mean, there's lube everywhere, which is good. I don't actually know where that really horrible feel was coming from. It could have just been unevenness on some of these teeth that would maybe wear away over time. I don't see anything terrible, though. So... yeah, you know, I might just like put some epoxy and some lube in this and then let's close it up and run it for a bit. I mean, I shouldn't do too much with it until the epoxy cures, but it honestly doesn't seem like I need the epoxy for that much right now, so maybe it's not a big deal. It'd be nice to look at it here, but we can't really run the motor without the top case on. I mean, I could try running it really slowly, but there's a chance it destroys something by being misaligned. Let's just give it a couple of volts. Back to 2 volts at half an amp. I'm gonna get a better camera angle too, or a better zoom. Oh yeah, that's a good point. Station 240 says that the off-center pin might have made the gear elliptical and kind of off-center. Yeah, maybe I should reprint this instead of just gluing this one on. I'm schmooing everywhere. It just got pretty jammed. Oh. Yeah, well, that's a good point. Let's, I'm gonna put some gloves back on and take this off, and let's look at how circular our gear is at this point. Oh, 2 goes on the rack. Actually, minor detour to point the cat camera at the cat. gimbal started up. Oh, that's a great idea. Joel was suggesting, okay, the suggestion I didn't understand earlier was actually to use the other 3D printed gear from earlier as a spacer while I was pressing that in with the vise. Oh no. Alex is suggesting to laser cut an acrylic gearbox cover. Right. Let's just make some out of transparent aluminum. Zoom, oh, overshot. That was the cat. Let's go back. Does the computer see him? I think so. So, aside from the off-center pin though, and the what definitely seems like a 1 hertz wobble related to that, yeah, I think that this seems alright. Like the helix angle looks great, and the pressure angle seems like it's fine. Seems like it's definitely close enough. That is, oh, I managed to take the bushing out with that somehow. So anyway, that's the whole output shaft bushing spacer gear assembly. I'll just put that aside. So for this, I suspect I'll have to press it out with the vise or cut it off again. Pressing it out with the vise might be easier. Let's find out. This gear just slides off, and let's save the key. And save, not drop. Save, not repeatedly drop. Alright. Well, hammer maybe. I could probably put this on top of my vise and then just hit it with a mallet a few times and get it out. Mallet. So there's definitely a bulge on this left side of the gear. Like, yeah, it's kind of cinched together the material on that side of the gear, stretching it. It's very strong though. Like, I'm pretty impressed the plastic didn't break during that process. Yeah, something I can poke this out with. Oh, this is about the right diameter. Oh, not enough oomph there. There we go. Alright, there's the shaft. Good as new. And, oh, there's our slightly distorted gear. Okay. How far off was that? We're obviously headed back into CAD, but geez. It looks like it's just entirely to one side of the center line. So if that's the center line in the middle, I think we've got the whole thing down to the below. Christian suggests filing the channels slightly to make the pin fit and then filling everything with epoxy. I mean, you could do it that way, but that seems extremely tedious. I'd rather change the design and reprint it, especially since I need to reprint it anyway because this gear is damaged. But that's basically what we're doing. Like, I'm just changing the position of those features and then reprinting it. This gear is only like a 30-minute print anyway. So we can also make the channel a little bit wide. I probably will go ahead and put some epoxy in because, well, I guess it's probably worth another test fit. But the thing is, if I have to destructively-ish get the gear off, then I might just go ahead and put epoxy in the first time I put the gear on. And then if it works, I'm done. And if it doesn't work, I just have to also take off the epoxy when I'm taking the gear off. I think that might be where we're at. But if we're going that route anyway, then I can make the channels a bit wider pretty easily. Alright, back to CAD. Oh yeah, how's the printer doing? Wake up. Still making that gear. Alright. Well, depending on how this goes, this might end up being kind of a short stream where I design a part and then I'll have to get back to you once I've got the next version printed. Oh, nice. Tim in Twitch chat says that they've been keeping up with the streams after the fact, and it's been great to see the spools running completely for a bit. Yeah, that's been great. Oh no. And then Tim has also been having problems with YouTube where the chat was disconnecting and then they couldn't add videos to playlists. That's weird. Anybody else having that problem? Cat. I don't think we need quite that much of a view. There we go. Alright, here's our gear thing. Gear thing. Yeah. So, I'm liking this design for the most part, but we need to change this sketch. Edit. So the pins were like exactly 2 millimeters in diameter. That additional is just our allowance for 3D printer tolerances and wiggle room. So I want to get rid of that. Let's make this a whole 3 millimeters. And actually, how do I want to do this? I could make something and dimension it as 2 millimeters to kind of stand in for where I think the pin is. And then just make this centered around that. Okay, cool. So now we've got this pocket that extends what should be like a 1/4 millimeter above and below, or 1/2 millimeter. It's a little close at these corners, but I think we'll be all right. It's a very minor change. And did our extrusion update? That looks right. Alright, I think that's all we needed. Let's bump the revision number and get this slicing. Same parameters as before, I think. That was working pretty well. Oh, yeah, that's actually a little too thin there. All right, we can't go quite there. I need to round off those corners. I think I've got enough clearance to do that. That's a whole millimeter. I think that should be plenty. That's maybe even too much. 3/4. I'm going to save that with the same revision, because I didn't even print it yet. Reload. Yeah, Station 240 says, plus if another gear fails in the future, it's easy to make one. Yeah, these are actually easier to make and install and all that than they could be for sure. It seems like it might be relatively easy to replace in the future. That's better. That's obviously a weak point, right? But I'm going to fill that whole area with epoxy. And it's so off-center. Okay, is it off-center on the right side, first of all? I should actually be asking these questions. I think so. I mean, yeah, no, it doesn't matter. It's symmetric along that axis. So all that matters here is the handedness of the helix, and that's correct. So that I can just rotate the shaft 180 degrees and it doesn't matter. There's nothing else that needs to be timed on that shaft. Alright, let's get that ready to print. Alright, well the printer is still printing this gear. I think this G-code file actually has multiple gears in it, and I only need the first one, so I might stop it after it gets past that. I don't know why of these cameras keep going blank. This might be a new OBS feature. Oh, interesting. Electron Ash adds that YouTube was having some known issues last night, I guess. Well, I think we might be at another point where I have to switch gears a little bit because we're waiting on this to print. And I could just launch into something completely different right now, but this might be a good reason to do that on a slightly different stream. Alexi says, would it be easy enough to fill the space between the teeth where the worm does not touch the gear to increase strength? You mean like make the actual helix part of the gear smaller and just make more of it just a cylinder or something? Did anyone see the gear shift, or was it an encoding glitch? I didn't see that. It might have been the Z table moving down. It might have been an encoding glitch, I don't know. I mean, it is a herringbone gear. It looks right to me. Like, the surface is a little irregular because I think this batch of NinjaFlex has some moisture in it. And so it's been a little bit bubbly as it prints, but it's not been too bad. And it's behaving very similarly to when I printed the last gear, so I expect it'll be plenty strong enough. When I was originally designing... Oh, weird. I just saw that. That was super strange. I think that was an encoding glitch, but that looked super concerning. Yeah, Joseph says for a split second it looks like it was loose from the table and moving with the nozzle. I'd be really surprised though, because this is NinjaFlex. NinjaFlex is actually kind of hard to remove from the build surface. So I'd be surprised if it was just sliding around like that. Here, I have to keep resetting that overhead camera. Oh, I see. A concave gear form. I mean, that seems cool. Do you have a way of generating that? I mean, that seems like a cool, completely additional side project to figure out how to make a gear like that. Huh, Mako MK says they've been getting YouTube glitches where they get randomly audio from the wrong part of the stream. That's not too weird, I guess. I think the audio and video get streamed separately on YouTube a lot of the time. Well, congratulations that 69 of you are watching on YouTube as we 3D print a herringbone gear. I mean, we're also watching the cat sleep, which is pretty great. I mean, we could also watch the robot fly around. Wow, is this camera also going to need to be reset? This has got to be something new in OBS. Anyway. So we can drive that around with three winches. Since 3 winches doesn't have any redundancy, I didn't want anything especially heavy up there, so I'm driving a slightly lighter spool of wire. The one I was using to stand in for the robot is about the same weight as the robot, at about 1.5 kilograms, but this one's only like half a kilogram. So here I'm just driving one winch at a time. And it's nice. It's stuck in the triangular prison. Yeah, Station 240 says gear geometry is pretty complex. Some areas appear to be air gaps but are needed for teeth backlash. Yeah, I mean, I wouldn't expect it to be trivial to generate something like what Alexi posted. It looks cool, but like, it seems like a whole additional project just to figure out how to make something like that, which I don't think we need right now. But if you can point me toward a way of doing that, then maybe I could try it. Welcome to everyone who's just joining us. Sorry this is not super exciting right now. I'm mostly waiting on the 3D printer, I think, and feeling a bit stuck, and like I might have to abandon stream soon until we have a free printer. So I've got this printer working on a different part currently. It's working on the flexible gear that we'll need for this winch repair. And I also need a new version of this little plastic gear that we designed on the last stream. We just tried it in the gearbox, and it seems to be good so far, except that it's got a bit of a occasional scraping, which seems like it's probably likely due to how we had to force it around this off-center pin. And so I think that actually kind of gathered up the gear on that one side a little bit. So it's a good sign. I think there's a good chance that once we print a new version of this gear and epoxy it on the shaft and properly lubricate this motor, that the motor will be working again and we can actually like do some high strength tests with it and or put it back in the winch. So that could be cool. I've also got another, like one of the, like this is just one strategy of a couple. So I'm trying to replace this gear, or replace the gear to repair the motor. I'm also trying to just replace the whole gear motor, which is not as optimal because like the exact supplier that I got this from was on AliExpress. So it's like a $50 motor plus a slow trip from China. I think I found a supplier with the same motor on Amazon Prime, and I ordered one of those, which should be here tomorrow, but I'm not 100% sure it's the same motor. So we've got a couple of potential options, but this gear repair is starting to look better actually, so. Oh, glitchy audio? Sorry about that. Does it sound like compression glitches or like radio glitches? How does that sound like over here? Sounds right over here on my end. Is this still fine, like right now? What? Alexi said audio was glitching in the previous stream too. That's weird, because like I usually spot check the recordings afterwards and I didn't notice anything wrong. Did like which platform, and did you notice it at a particular point or just all over? Can you be more specific? Okay, now it's crackling. I see it now. All right, hear it now. That sounds like radio interference on my wireless mic. So yeah, like this right here, that's the radio interference. So like I expect a little bit of that because the radio is not perfect, but if there's a bunch of that, we can switch to the wired mic. That's just why I want folks to be pretty specific about what kinds of audio problems we're having, if we are having any, because I can resolve a lot of them, but I just need to know like what kind of thing it is. So now we're back at the desk mic. And this should not have any radio problems, but it might have other problems. Taylor says maybe interference or loose connection. I mean, yeah. When I was just listening to it just then, it sounded like radio, like analog radio interference. Mr. Radar says it was sounding like a buffer overrun or underrun. Really? I can't fathom how that would be happening right now, but okay. Sounds like clipping. Huh. Okay, whatever. Well, I mean, I'm almost done with this stream anyway. I'll try to debug it later. Paul is asking... You're asking about what version of... I don't know, like, what... I'm gonna ignore that question because I don't know what you're talking about, sorry. It didn't seem like it was clipping on my end, but I mean, you're listening to a slightly different signal than I am, so I'm gonna have to just check the recording later. There isn't much I can do about that right now. Alright, well, I'm tired of this. I don't have anything more to do, and I'm feeling antisocial, and I kind of want to just go away, so I think I'm going to do that. But yeah, I will be back as soon as I have a new gear. I'm just going to take a break until I have a 3D print and do something different, and keep you up to date about what that ends up being, I guess. But, okay, yeah, so, like, I'm just getting, like, all sorts of different theories about what the sound problem might be, which is, you know, they're all different. That's great. Alright, bye.